What is domain name system? What is DNS? How this DNS work? And why we need the DNS? The first question talking about DNS, domain name system, is why we need it. So as a human being, we are very good with language and words, but we generally don't like to remember numbers that much. For example, if you have a mobile number, this mobile number, if it is mapped with, say, name Tom, then this Tom will be easier for us to remember rather than remembering this whole mobile number. Though it is possible to type in an IP address into a browser to reach a website, but most people want an internet address to consist of easy to remember words, and these are called the domain names. For example, if you see here, www.github.com is better than the IP address of the same. In 1970s and early 80s, the task of matching domain names and IP addresses, it was assigned to one person called Elizabeth J. Feinler at Standard Research Institute, who maintained a master list of every internet connected computer. This was unsustainable given the rapid growth of the internet. In 1983, Paul Mockapetris, he developed DNS, domain name system, an automated scalable system that handles domain name to IP address translation. So there are currently more than 367 million registered domains. So keeping all these names in a single directory would sometimes be very difficult and cumbersome. So like the internet itself, the directory is distributed around the globe on domain name servers that communicate with each other on a regular basis to provide update and eliminate redundancy. Another reason for creation of this DNS information distributed system is to boost performance. Now imagine if all requests coming in at the same time all over the world to resolve the domain name Google with the underlying IP address being handled in a single location. This means a single domain can have more than one IP address. For example, the physical server that your laptop or smartphone reaches when you enter the google.com is different from the server that someone in another country would reach by typing in that same site into their own browser. But DNS still gets you to the right place no matter where you are in the world. DNS or domain name system. Now what is it? See, whichever your browser is, it can be Opera, it can be Chrome, it can be Firefox, the first thing you do is type in certain words. Those are called the domain name. So www.google.com is the URL. And do you know the IP of this URL or this website, web link? No. So computer as a digital device, they only know or understand the numbers, specifically the digital numbers. We are not very good with the numbers. If I tell you the IP of this is 8.8.4.4, you may remember it, but I doubt for long run. So the best way is to know the name and convert it into IP. So the name to IP conversion is the work of domain name system. Human or as an individual, we always access information online through domain names like google.com, espn.com, yahoo.com, like this. So this google.com and espn.com is nothing but the domain name. And these domain name are associated with the IP number. So the domain name system can be considered as a phone book. Previously, we used to have a name and then we have a number. So that is how we map it. So it's just a mapping. Domain name system is just a mapping from name to IP. So this is a phone book or a directory of the internet. You can consider this like this. On the left you have name and on the right you have IP. So when you type in the name, the IP should come up. And that is the whole work of domain name system. So DNS is nothing but a directory service that provides mapping between the name of the host on the network and its numerical address, which we are calling as the IP address. It can be IPv4, it can be IPv6. And this IP is actually replaced by the name of the domain, and that's how you can get hold of the website or the web content. So web browsers, as I just told you, they interact through internet protocol, IP addresses. So this is a network layer I'm talking about. You see a IP. This IP is implemented using the IPv4 and IPv6 addresses. Okay. So web browser can only interact through IP addresses. So it should only know the IP addresses. The name you are typing has no meaning. www.google.com has no meaning for the computer or the network. It is only for you to understand, to remember. So each device connected to the internet has a unique IP address. That is how it is known all over the network. Okay. So which other machines they would like to know? Find the device, find the IP. So this is the DNS translation. So DNS translation, or it translates domain name to the IP address, so the browsers can load the internet content or resources. Okay. So whenever you type in www.google.com, this 8.8.4.4 should come. That is why the DNS, if you see here, it is an application layer protocol. It is an application layer protocol. And when you talk about domain name system, there are domains. So each node, there is a proper tree, has a domain name. The full domain is a sequence of symbols associated with a dot. For example, www.google.com. So the rightmost .com is nothing but the top level domain. So this top level domain will go to the recursor, the resolver, then it goes to different servers. Finally, your IP will come through this www.google.com. So this .com is first being known. So this .com is a top level domain. So DNS servers eliminate the needs for users to memorize, to remember IP addresses like IPv4 and IPv6. IPv4 ladies can remember. How can IP address of 128-bit, that is the IPv6, can be remembered? Those having hexadecimal values? No, it is not possible. So that is why we need DNS. Therefore, we have 4 servers here. In domain name system, we have 4 servers: DNS resolver or recursor. Then we have root name server. Then we have the TLD or top level domain name server. And then finally, you have the authoritative name server. So this domain name system resolver, it gets the IP, this URL. It gives it to the root name server. Root name server will tell you, okay, this is .com. So you have to go here. This is the .com server, because there are different server in the world for .com, for .edu, for .org. So this is how this different server will contain that website, and that website is equivalent to or is related to some IP address. So then the authoritative server will come in place, where hostgator.com or godaddy.com you have registered your website, and that information is available in the TLD name server, and it is checked and verified by the authoritative name server. So this is how the final conversion of the domain name to IP is done using these servers. So this is how the domain name system works, from name to IP address. It only finds that, okay, to download the web content. What are DNS servers and how many servers are there? How do they work? So first of all, these are the 4 different servers that will play a role: DNS recursor or DNS resolver, root name servers, the TLD name servers, the authoritative name servers. So this DNS resolver or recursor It can be thought of as a librarian who is asked to go to find a particular book somewhere in the library. Now this DNS recursor is a server designed to receive queries from client machine through applications such as web browser. Typically, the recursor is then responsible for making the additional request in order to satisfy the client's DNS query. Then comes the root name server. This root name server is the first step in translating or resolving human readable host name into IP address. So this can be thought of like an index in a library that points to a different racks of books. Typically, it serves as a reference to other more specific location. So this Internet Assigned Numbers Authority is in charge of these servers. Then we have the TLD or top level domain server. So this top level domain server can be thought of as a specific rack of books in a library, and this name server is the next step in the search for a specific IP address. So it hosts the last portion of a hostname. So in this GitHub, the TLD server is com. So this TLD name server keeps track of all domains named with the same domain extension such as .com, .net or whatever comes after the last dot in the URL. This .com, for example, a TLD server includes information of every website that ends in a .com. So if a user search for say google.com or github.com, the DNS resolver would submit a query to a .com TLD name server, which would answer by referring it to the authoritative name server for that domain. So this authoritative domain name server, or you can say authoritative name server, this final name server can be thought of as a dictionary on a rack of books in which a specific name can be translated into its definition. So the authoritative name server is the last stop in the name server query. If the authoritative name server has access to the requested record, it will return the IP address for the requested host name back to the DNS recursor, the librarian here, and that made the initial request. So this is how the DNS server work, and this is what they are for. How does a domain name system or DNS work? So you can ask or you can type in your web browser to load a website. Since computer don't speak English, your browser can't read a name like github.com or some website, and instead it needs an IP address. Because of this, it sends your request to a DNS recursive resolver. The DNS recursive resolver, the goal of it is to find the IP address connected to your website that you have entered in. So the resolver first step is to find the website's top level domain or TLD. In other words, whether it's a .com or a .net or a .org or another type of site. It does this by asking the root name server, which keeps a list of every website in its TLD, in each top level domain. So once the resolver asks the TLD, it goes to the corresponding TLD name server, for example a .com name server, and asks it to find the right IP address. So this TLD name server finds the IP address and hands it off to the authoritative name server, which will figure out if that address is correct. The authoritative name server sends a message to the address and waits for a response. If it gets the response right, then it has the right IP address of the website you want. So if the IP address is correct, the authoritative name server sends it back to your browser. Once your browser or web browser receives the right IP address, your web page starts to load. Domain name system has a structure, because if you want to implement a domain name system, there has to be certain laid down rules. So in your web browser, you type certain website, and here you see you have a .com. It can be .org, it can be .net. So this .com is nothing but the top level domain. Okay. So this top level domain is generally, you will find it in the URL. In the web browser, whatever you type, this domain name comes from there. In this case, if you see, .com is where? Universal Resource Locator, whatever you type in, gives you the domain name, which is the rightmost. So the domain name is made up of multiple parts. So you can call them as labels. And this domain is a hierarchical structure. So this is read from right to left, and with each section denoting a subdivision. Okay. Top level domain, that is why we are calling it as .com, because it is on the rightmost. So the TLD, top level domain, it appears after the period in the domain name. For example, .com, this URL is having .com, but a URL can have .org. It can have .edu. These are all top level domains. So when you come here .com, and there are multiple servers, .com will have its own server, .edu will have its own server. So each label on the the left hand side of the TLD or top level domain denotes another subdomain of the domain to the right. So everything on the left of the right is actually the subdomain of the right. For example, in this www.example.com, example is the subdomain of .com. Okay, and www. Is the subdomain of example.com. So there can be up to 127 levels of subdomains. It is not just one which we know. It can be, this can go up to 127 levels of subdomains, and each label can have up to 63 characters. .com you cannot change, .edu you cannot change, but these subdomains, like for example this example is there, it can be Google, it can be some other thing. So the total domain character length can have up to 253 characters. Labels, which is laid down rules, labels do not start with a hyphen, and it cannot have all the numbers as numerals. That is, it cannot have entirely numeric TLD names. Therefore, whenever you type something like this, you get a proper directory structure from where your IP will come through domain name. So the IETF, the Internet Engineering Task Force, has specified the rules about implementing domain names in RFC 1035. So this whole criteria is used to actually find out the IP through this domain name. So this domain name structure needs to be known in order to get the IP from different servers.